Hello, Integrated Math 1. Welcome to lesson R.7-4. We're continuing to work with elimination. We're just going to use multiplication now. So in the past, we've solved systems of equations by graphing them, looking for where they intersect. We've solved systems of equations by substitution, where we get a variable alone and then we stuff it into the other equation and work it out from there. And then last time we were talking about using this process called elimination, where we added or subtracted our equations together to eliminate one of the variables to be able to solve for the other one and work our way through from there. We're going to keep playing with that today. We're going to keep using that elimination method, but we don't want to forget our old method. So I do have a warm-up problem for you. I would like you to use substitution to solve this lovely system of equations we have sitting in front of us. So go ahead, hit pause to work this out, and then hit play when you're ready to check your work. So I was looking at this equation and I thought, that y is a coefficient of -1, which isn't exactly what I wanted, but it's pretty close. So I'm going to do this. I'm going to go ahead and add y to both sides. So I have -4x equals y minus 4, right? Positive y and then -4. Oh, and that means I can add 4 to both sides. So I have -4x plus 4 equals y, which is perfect because now we're going to use that substitution that it did say to use. I do use substitution. So everywhere I see a y, I can substitute in -4x plus 4. Since I used the second equation, I'm going to plug it into the first one. So I'm going to do this. We've got 5x plus 2 times, instead of y, we're going to put in -4x plus 4. Equals -1. And then we're just going to solve from there. So let's go ahead and distribute this thing. So I have 5x minus 8. 2 times the -4 is -8. 8x, sorry. And then 2 times 4 is a positive 8, and it equals -1. I have some like terms here. 5x minus 8x gives me -3x plus 8 equals -1. And we'll go ahead and subtract 8 from both sides. So I have -3x equals, let's see, -1 minus 8 is -9. This is going to work out so well. So I'll divide both sides by a -3. Oopsie. Those will cancel out. -9 divided by -3 gives me a positive 3. Now, I've only found x. We still have to find y. You can plug it into whichever equation you like. I don't really care. I'm going to plug it into this one. Why not? I'm going to use the first one. I'm going to grab another color, though. I'm also going to erase that line in the middle because that's a mess. I don't want the space. So I can do, instead of 5x plus 2y equals -1, I'm going to do 5 times 3 plus 2y equals -1. That, of course, is 15 plus 2y equals -1. If I subtract 15, that gives me 2y equals -16. If I divide by 2, I find that y equals -16 times 2 is a -8. Don't forget to write your answers in ordered pair. So I'm going to write my answers in ordered pair. My x coordinate is 3. My y coordinate is -8. Boom. So that was a little bit of a throwback. But we've been playing with elimination recently, right? We've been adding together our equations to eliminate one of our variables. And I really like elimination because once you get rid of a variable, oh my gosh, it's so much easier. It's so much faster. I love it. The only thing is, last time our coefficients either were opposite coefficients, so we just added the equations together, they took care of themselves, or they were the same coefficient. So we subtracted our equations to make opposites and eliminate one of them. But we know that that's not always going to happen. So what happens if you don't have opposite coefficients or the same coefficient? Well, we got to use multiplication. So you can solve systems of equations by elimination with multiplication. This means that your first step is that you're going to have to multiply at least one equation by a constant to get two equations that contain opposite terms. If you're looking at that and you're like, I need my coefficients to be opposites, I don't have any opposites, multiply your equation by something to make opposites. And then step 2, add your equations, it'll eliminate 1, solve the equation, and then of course substitute that value from step 2 into one of the equations and solve for the other variable. Remember to write the solution as an ordered pair. So if we come over here, example 1 on page 413, I would like to use elimination to solve the system of equations. But I see 10x plus 5y equals 30. I see 5x minus 3y equals negative 7. 10 and 5 are not opposites. They are not the same. 5 and negative 3 are not opposites, and they're not the same. So this is a classic case where I need to do a little multiplication. Okay? I'm looking at these guys, and I realize if I doubled 5, it would be 10. But I want them to be opposites. So I'm thinking I should multiply by a negative 2, right? Because the coefficient of x, they'll be opposites if I multiply this second equation by a negative 2. But you know the rules. We can't just do it to 1. We have to do it to everybody. So I'm going to multiply this entire second equation by a negative 2 to create opposites. Okay? Grab my red pen. So I'm going to multiply everybody by a negative 2. So negative 2 times 5x is negative 10x. Negative 2 times negative 3y is a positive 6y. And negative 2 times a negative 7 is a positive 14. Now, I'm not going to use this one anymore. I'm going to use this guy. So I'm going to add my first equation with the new version of my second equation. Now I can add my equations together. And at this point, I think you can figure out the rest of this. So go ahead and hit pause, work out the rest of this, and then hit play when you're ready to check your work. So I added my equations together. Of course, 10x and a negative 10x, they canceled out. 5y plus 6y is 11y. 30 plus 14 is 44. I had to write it up here because I was running out of space. I'll go ahead and divide both sides by 11. So those cancel. And I get that y equals 4. Of course, now I'm going to substitute 4 into either equation to find x. I don't care. Just pick one. I'm going to pick the top one because it's convenient. So instead of 10x plus 5y equals 30, I'm going to say 10x plus 5 times 4 equals 30. Of course, 5 times 4 is 20. Ooh, and we know what to do. We're going to subtract 20 from both sides, right? Pew. 30 minus 20 is, of course, 10. And then this is pretty easy. We divide both sides by 10. 10 divided by 10 is 1. We get x equals 1. Don't forget to write your answer as an ordered pair. My x-coordinate is 1. My y-coordinate is 4. So the solution is 1, 4. Yay. Good job, us. All right, I have another challenge for you all. I would like you to do example 2 on page 414, and I'm going to give you a hint. We multiplied one equation to get opposites, but you could multiply both equations by different constants to create opposites. You could. That's allowed. Go ahead and hit pause. See if you can work this out, and then hit play when you're ready to check your work. So, 3 and negative 2 are not opposites. 4 and 3 are not opposites. And I don't see that little like double it to match it up trick. So I'm actually going to have to multiply both equations by a constant. Now, it shouldn't be random. The idea is we're trying to create opposites. So I'm going to try and create opposites with my x's just because one's positive and one's negative. So I feel like that'll be easier to create opposites. So if I multiply the first equation by 2 and I multiply the second equation by 3, that should create some opposites for the x's. So I'm going to start by multiplying my first equation by 2. And we're going to distribute, we're going to distribute, we're going to distribute. So 2 times 3x is 6x, 2 times 4y is 8y, and 2 times a negative 22 is negative 44. So I'm no longer going to use this one. I'm going to use this guy. Oh, we said the second equation, we should multiply by 3 to create opposites, right? So I'm going to take that second equation, I'm going to multiply it by 3. So distribute, distribute like crazy. 3 times negative 2x is negative 6x. 3 times 3y is 9y. And 3 times negative 8 is negative 24. So instead of this equation, we're going to use this one now. All right, I've created 2 new versions of my equations, and so I'm going to add them together. And we deliberately created opposites here. So 6x minus 6x, goodbye, have a nice life. 8y plus 9y is 17y, and negative 44 minus 24 is negative 68. I'm going to go ahead and divide both sides by 17. I hope that works. That seems like an awful number. I'm going to grab my calculator. Negative 68 divided by 17 equals, oh, it actually worked out nice. It equals negative 4. Yay. Whew, I was worried. All right, now we can substitute negative 4 for y into either equation. I'm going to come back to the originals. I'm just going to use the top original equation. I really don't care which equation you use. It'll work for any of them. So negative 4, I'm going to plug that in. So instead of 3x plus 4y equals negative 22, I'll just do 3x plus 4 times negative 4 equals 22. Of course, 4 times negative 4 is a negative 16. Ooh, and I'm going to go ahead and add 16 to both sides. So those will cancel out. 22 plus 16 is negative 6. Yeah. And then we'll divide both sides by 3. And that cancels out. So I get x equals negative 2. Don't forget to write your solution as an ordered pair. My x coordinate is negative 2. My y coordinate is negative 4. Awesome. Sweet. Okay. Let's do one little real world example. We should do at least one. So this is example 3 over on page 415. And we're going to talk about George's comic book collection. So George's comic book collection consists of single issues that cost $4 each and paperback collections that cost $12 each. Now, he has 100 books in all, and his collection cost him $616. So I would like you to write and solve a system of equations to determine how many single issues and paperbacks George has in his collection. Go ahead, hit pause, see if you can work this out, and then hit play when you're ready to check your work. So first of all, I'm going to use a C. I'm going to use a C for his single issue comic books. And then I'm going to use a P for the paperback collections. It just seems easiest to do. And I know that his single issues plus his paperback collections should equal 100. Okay, so C plus P is 100. But let's talk about the cost. I know that it's $4 per single issue, so that'll be 4C, plus $12 per paperback collection, so 12P. And together, that should equal that $616. Awesome, awesome, awesome. Now, I don't have opposites, so let's create some opposites. I reckon I can multiply this first equation by a negative 4, and that'll make the C's opposites, right? That'd work pretty well. So negative 4, multiply everybody by a negative 4. So negative 4 times C is negative 4C. Negative 4 times P is negative 4P. And negative 4 times 100 is negative 400. And now that I've written it, I'm going to erase it so that you can see my pretty typed up version. Yeah, better. Great. So now I'm not going to use this one anymore. I'm just going to use this guy here. And now I can add my equations together. It'll work out well because negative 4C plus C, bye-bye, see you later, so sad. Negative 4P plus 12P is 8P, and negative 400 plus 616 is It's 216. We'll go ahead and divide both sides by 8. We get P equals 27. Ooh, but we have to figure out how many single issue comics as well, right? So let's go ahead and let's take that P. We're going to substitute 27 for P into either equation to find the value of C. I don't care which equation. So I'm just going to use that top one again, C plus P equals 100. Only instead, I'm going to do C plus 27 equals 100. And I can just subtract 27 from both sides. 100 minus 27 is 73. Now, I'm not going to write an ordered pair this time. It is a real world problem, so I do want to make sure that I'm actually going all out here. So George has 73 single issue comics. That's not correct. And he has 27 paperback collections. There's a typo. Hang on, I can fix it. I feel like there's been a lot of typos lately. Do you feel like that? I'm going to fix it real quick. Bring it back. Boom, there we go. So George has 73 single issue comics and 27, I can say this, paperback collections. Awesome. Well, thanks, guys. As always, I hope you found this helpful. I hope you found this useful. If you have questions or concerns, please feel free to email me or come talk to me. I'm around, and I'll see you guys soon. Bye.